Welcome to this video on Tutorial 9, Polar Coordinates and Inequalities. In one dimension, polar coordinates are actually really simple. All we see is the real line, there's 0, and suppose you take a value x. Then this size, you can think about it as the absolute value of x, or size, we sometimes call it r. And if I went the other way, if I have a negative number, there's minus x, I can distinguish these two by thinking of x is equal to, I'm going to write it in a funny way, r, comma, the sign. Write a little subscript p for polar. Where here the sign is just plus or minus 1. And r is equal to the absolute value of x. It's also known as the size, or modulus. Lots of names. More accurately, more mathematically, the size of x is equal to x if x is greater or equal to 0, or minus x if x is less or equal to 0. So for inequalities, so we're doing two related topics today. Moving on to inequalities, if I take two numbers, x or y, exactly one of the following holds. X is either less than y, or it's bigger than y, or they're equal. Exactly one of these holds. This is known fancifully as the law of trichotomy. So in particular, we have the following properties. If x is less than y, okay, well, now we're going to have three numbers, and y is less than z, then x is less than z. If x is less than y, and you take any z, x plus z will be less than y plus z. You can add two numbers. And if x is less than y and z is positive, then xz is less than yz. You really need that this z is positive, because here's a classic error. If you take, it's the following, if you take, say, 2 is less than 3, and z is equal to 5, we do get that 10 is less than 15. But if you take z is equal to minus 5, we get that minus 10 is bigger than minus 15. It's less negative. So the sign changes if z is less than 0. So let's do an example for a problem. The perimeter of a rectangular swimming pool is not to exceed 70 meters. Suppose that the length is to be twice the width. What width w will meet the conditions? So first things first is to draw a picture. So we have the width and the length. It's rectangular, so the widths are the same. And we know the length is twice the width. So the perimeter P, let P be the perimeter, then P is equal to, well, it's 1, 3, 4, 5, 6 W total. And the requirement is that it must not exceed 70 meters. So to be less or equal to 70 meters by, let's say, by star. And of course, there's actually secretly another one. Also, W has to be, let's say, positive. We actually want an actual swimming pool. Therefore, W bigger than 0 and W is less equal to 70 over 6. If you want to combine them, you can write as W bigger than 0 and less than 70 over 6, and it's in meters. So let's do another example of inequalities or absolute values, and bring back the notion of polar coordinates or size. So let's represent size of x as less than 5. The way we should think about this is that the distance of x from 0 is less than 5. On our picture, what we want is there's 0, there's 5 one way, there's 5 the other way, and x should be in this range. Similarly, if we draw, instead of x being the size of x being less than 5, let's just say that the size, or modulus, or absolute value of x minus 2 is less than 5. Pictorially, we would think that this means that distance of x from 2 is at most 5. So here, let's show that this actually happens. So this is 2, there's 7, and there's minus 3, there's 5. And we think that this should be in this range. Let's prove it. So let's go back to our equation. So case, if x is bigger or equal to 2, this thing, the absolute value of x minus 2 is x minus 2. And our condition is that it's less than 5, which implies that x is less than 7. So in this part, x is bigger or equal to 2 and less than 7. So that's this piece here. And in case 2, if x is less or equal to 2, then the size of x minus 2 is equal to minus x minus 2, and that still has to be less than 5. And this means that minus x plus 2 is less than 5. And just to get my signs right, that means that x is greater than minus 3. And you see that this is exactly this piece. It overlaps. Minus 3 is greater than x. Is small equal to 2. So that overall solutions are, as promised, is the red piece, x lies between minus 3 and 7. Okay, so moving back again, these are roughly related ideas. Let's go back to a new topic, polar coordinates in 2 dimensions. I know that you wanted to see stuff on polar coordinates. So we did the one-dimensional case, which was just absolute value, which was just size. And in 2 dimensions, the idea is that if I give you a point, of course you can talk about its x-coordinate and its y-coordinate, but if you let the point be z, the size is the distance of z from 0, and if if I take this angle, that's theta, this should be looking very familiar from trigonometry. So that theta, so that we have two different ways of representing the point z, which is a point in the plane, either traditionally as x comma y, or as r cos theta, r sine theta. This is the rescaling. Remember that the base is r cos theta, and the height is r sine theta. I might write this as r comma theta sub p in polar coordinates. This again is the size, absolute value, modulus, and here there we have the angle. It's also known as argument. Funny name. So here, just to conclude again, by Pythagoras, r, which is the size of z, is just the square root of x squared plus y squared, and the angle theta is given by tan theta, which is opposite over adjacent, which is equal to r sine theta over r cos theta, is equal to y by x. So let's do just a couple of quick examples of polar coordinates. Let's do the same thing as above, but this time within 2 dimensions. Let's draw z is less than 5. So this means that r is less than 5, so that the radius is less than 5. So if I had to draw this, there's 5. I would just draw the circle of radius 5. Well, that's not a great circle I've drawn, but you get the idea. And it's all of everything in here. So at a point z, the distance from the origin is at most 5, less than 5. The similar example of z minus 2 being less than 5 is a little bit more different, because this is the distance of a point from the point 2, which is understood as I've been a little bit imprecise. What do I mean by 2? I suppose I should really write 2 comma 0. That's x, that's y, there's 2. And so here's minus 3, there's, let me redraw this slightly, apologies. And it would be this circle. I just realized that note, this is it's different to saying that r minus 2 is less than 5, because this would just be r less than 7, and so you get the circle of radius 7.